You know that feeling. You see the news, a super typhoon is spinning up over the ocean, or the ground starts to shake. And in those first moments, chaos is the real enemy. First responders are getting overwhelmed, crucial information is scattered everywhere, and every single second counts. It's this frantic race against the clock, and we're talking about entire communities on the line. So the big question is, how can technology help us turn the tide? But what if we could flip that script? What if a city could almost anticipate a disaster's every move? Imagine a digital nervous system that could not only see a threat coming from miles away, but could instantly diagnose its impact and coordinate a perfect response automatically. Look, this isn't some far-off sci-fi idea. For millions of people who live in the path of natural disasters, developing this kind of sixth sense, well, it's a very real and very urgent matter of life and death. So let's play this out. Let's imagine a scenario. Super Typhoon Amihan, an absolute monster of a storm, is turning its way toward the coast. Normally, panic would be setting in, but for our city, something different is happening. A system is waking up, and its name is DGRVM. The best way to think about DRLVIVM is as the central nervous system for the city's entire disaster response. It's a framework built from the ground up to take in massive amounts of information and turn it all into clear, decisive, life-saving action. At its heart, it runs on this really elegant 7-phase intelligence cycle. It's a loop that takes you all the way from the first warning sign to building long-term resilience. We're going to see some of the most critical phases in action right now as Typhoon Amihan closes in. Okay, so the first domino to fall is detection. The system instantly starts pulling data from multiple agencies, like PAGASA, that's the Philippine Atmospheric, Geophysical, and Astronomical Services Administration, and the National Disaster Risk Reduction and Management Council. All of a sudden, this interactive hazard map just comes alive, tracking the storm severity in real time, visualizing every alert. The city doesn't just know a storm is coming, it can literally see it. But, just seeing the storm isn't enough. That's just step one. The really crucial next step is to understand exactly what that storm is going to do. The system has to move from detection to diagnosis. So how does it diagnose the risk? This is where it gets really smart. The system uses a standard ISO 31000 risk heat map. It plots the likelihood of something bad happening against how severe the impact would be. This immediately classifies all the potential threats, moving them out of the realm of pure guesswork and into a really clear framework for prioritization. And just like that, bam, it pinpoints the single greatest danger. Based on the typhoon's path and the neighborhood's known vulnerabilities, the system flags a critical flood risk for a really densely populated area, District 4. It even assigns it a score, which makes this abstract threat terrifyingly concrete. 9.2 out of 10. There's no ambiguity here, right? This is priority number 1. Action is needed, and it's needed now. And this just brilliantly illustrates the next phase, response. That critical score acts like a trigger. An AI-augmented system immediately suggests the best mitigation strategies. Automated alerts fire off to local emergency teams from the DILG and local government units. Pre-positioned flood barriers are deployed, and evacuation orders are pushed directly to the phones of every single resident in that danger zone. It's a coordinated, citywide response happening in minutes, not hours. Okay, so the storm passes, and thanks to that incredibly swift response, the city has weathered the worst of it. But the system's job isn't done, not by a long shot. Now, one of the most important phases begins. It's time to learn from the data and build lasting resilience. To do this, the system uses a framework based on the UN's 10 essentials for making cities resilient. Think of it like a report card. Before the storm, our city had a baseline score. Its governance was at about 65%, infrastructure at a kind of worrying 55%, and its emergency response was at a pretty solid 70%. Then Amihan hit, and on this next chart, you can see the impact right away. Infrastructure, as you'd expect, took a massive blow, dropping all the way to 35%. But notice something fascinating here. Emergency response actually went up. Why? Because the system proved how effective it was right when it mattered the most. And here's the real magic. The system takes all of that data, everything that broke, everything that worked, to drive improvement. So a year later, the city is genuinely stronger. Infrastructure is rebuilt to a higher standard, governance is more robust, and the emergency response is even more effective. This is how a city actually learns. This is what the enhancement phase is all about. The AI doesn't just collect data, it actively uses it to generate brand new, customized disaster plans. And we're not talking about generic templates. These plans are specifically aligned with Philippine laws like Republic Act 10121 and standards from the DILG, the Department of the Interior, and local government. That ensures they're not just smart, but practical and fully compliant. Now, with all this data and all these automated processes, you might be wondering how a human city planner or a mayor is supposed to navigate all of it. Well, the system has a guide built right in. Meet Dee Ivor. It's an AI chatbot, sure, but it's better to think of it as an expert consultant. It understands every single piece of data on the platform, and it's an expert in both international best practices and local laws for disaster management. What this means is a local official can just ask a question, and they'll get an immediate expert answer that's backed by real-time data and official protocols. It's like having a seasoned disaster management expert on call 24/7. And that brings us to our final thought. We've seen how a system like this can detect, diagnose, and respond to a disaster in real time. We've seen how it can help a city learn and grow stronger from the experience. So the big question we're left with is this: could an AI co-pilot, a true guide in the machine, be the key to building a future where our cities are truly resilient?